What's your minimum specification? Hi everyone. So today's interview is actually a really fun one. Joining me today is Rebecca Weekly, the new chairperson of the Open Compute project. In her day job, Rebecca handles hyperscaler strategy over at Intel, but is now chairperson of OCP that now oversees a number of the standards relating to hyperscaler infrastructure and server design. OCP has over 250 members, starting from 6. It's been around about 10 years, and about 16,000 employees at the different companies around this industry contribute to OCP's standards with regards to power, with regards to infrastructure, with regards to efficiency. There's networking, there's hardware, software boundaries. There's the Open Chiplet Marketplace initiative, ODSA, all sorts of stuff going on. And as the new chairperson, Rebecca is the best person to ask about it. So please let me welcome Rebecca to the channel.
I'm still drinking my coffee this morning.
Do you have the Intel mug though?
I don't have my Intel mug. I have my super cheesy "You Are Blessed" mug, which is absolutely true. It's like happy, amazing, generous. You know, feel the loves. Feel the loves. It's from my mom.
It's definitely good for a Monday morning, I think.
It's a Monday morning.
I guess let's start off there with the interview. You know, you've been elected as chairperson of the Open Compute project. So how long have you been involved with OCP? And what does your position as chairperson entail exactly?
Great question. So I have been on the board of OCP since September of last year. I started sort of, for lack of a better term, shadowing the previous chair or the previous person in the role for Intel back in July, but I took the position in September. I've been involved in projects with OCP for a long time. So because at Intel, I work with the hyperscale customers. 3 of those hyperscale cloud providers are on the board of OCP. And many of our projects, whether it's, Mount Olympus that was donated, in conjunction with Microsoft, or any of the Yosemite V1, V2, V3, which were donated obviously from Facebook partnership, those projects have been things we've been working on forever. Firmware support packages, open BMC. I mean, there's so many projects from a management and modular design point of view that are my day job, to work with customers to make sure that they have the kind of modular compute systems that are vanity-free, ready to go in the ecosystem. So it kind of always has been part of my day job since I came to Intel about 6 years ago. So it felt very natural, but the board is very different. It's a different way to think. When you come in and you look at an open source ecosystem and your contribution strategy to an open source ecosystem from a specific company, you think about, okay, what are the base components that have to be able to work together? How do we enable that while keeping our special sauce unique, right? That's our job. That's our responsibility to our various stakeholders. When you're sitting on a board, you're thinking about the future of that industry and the community you serve and what needs to happen in that industry given the big trends that are happening. And that has been, first of all, just being on a board with Andy Bechtelstein, who's kind of a god, but not in any way to, limit the list. I mean, everybody who I have the opportunity to serve with, Mark, Partha, Zaid, Jim, they're all phenomenal humans who really think about both of those and wear those hats with a lot of grace. And so, finding that opportunity to see what am I supposed to do for my job, what am I supposed to do for Intel, and then what am I supposed to do for this community correctly, and making sure that all can be synergistic, but recognizing I'm here in this capacity. That's the hat I'm wearing, and that's what I got to do.
Yep. And I guess at times they do conflict. If different parts of the board want to do different things, say, than Intel does, but it's just a general industry push, I guess.
Yeah, I mean, something I did very early on the board was I listed out all the different working groups, and I was totally explicit with my partners on the board which ones Intel's ignoring. It's
Yep.
not our job to contribute. We're not going to contribute in that domain space. We
Yep.
think we have a lot of, special sauce, and we're going to
Yep.
observe. We're there to participate, and hopefully we'll help ensure that, key contributions don't anything we can contribute from the sense of like that's not a great choice. We've been there, we've done that. Don't go down that path. But
Yep.
in general, we're observing versus where we're trying to lead, where we think it's critical to the future. So I went through, took all the projects, said what the status was, and really worked internally because there's so many different parts of Intel that do contributions to OCP, from tools, software, firmware, BIOS, everything that's happening obviously on the system side, and the systems components, whether it's a network add-in card or something that's happening at the switch silicon space versus what's happening on a true motherboard. So lots of different areas where people can contribute, trying to get everyone on the same page, truth and transparency, like where are we at, and then share that so that if a topic came up and I had to say, I can't really talk about that. It's not
Yeah.
something I'm either empowered to talk about, or it's just not something that I'm going to contribute to. I can speak as myself, but not in my capacity as working for Intel.
I mean, OCP, Open Compute Project, if people don't know what it is, go do some research, and it seems very focused towards sort of the enterprise, hyperscale industry. It's not going to be for people considering their own, home system or home networks. But how would you define OCP, I guess, to people who have never heard about it before?
Sure. OCP, as you said, Open Compute Project, it's really a community. At first and at most, it's a community. And it's by engineers for engineers, which is probably
Yep.
why I love it so much. It started in 2011. And fundamentally, it was really about efficient server, storage, data center hardware designs. And it's one of the few communities I know of, actually, in fact, the only community I know of that doesn't focus on, you know, thermal electrical protocol layers for interconnect in some
Right.
capacity, JEDEC, PCI SIG, whatever you want to say. It's about systems, it's about
Mhm.
implementations. And that combination of, okay, it's great to talk about a hardware root of trust, but folks, if you want everybody who's participating in your supply chain to have an implementation of a root of trust that is consistent, you got to go somewhere.
Yep.
You got to force, an implementation spec and a compliance body in some sense to make sure that happens. So it's really the only one I know of that does that work. And that, I think, is what, in many ways, I mean, if you think back to 2011, you still had SGI, you still had all these Cray, MIPS, companies doing MIPS was part of SGI at the time, but, doing implementations of very fancy, do you remember walking through the data centers with all the little LEDs and they were just so perfect and people were like manufacturing their own screws, as if
Yep.
that was important. And
Bespoke
this
designs.
yeah, exactly. And this community got together and said, we don't care if it's plywood. Like, it does not matter. Plywood would be a little hard to cool, but
Yeah.
conceptually, they didn't care. They cared about vanity-free hardware. How do we
Yeah.
drive convergence on vanity-free components to increase supply, to decrease cost, to improve PUE, everything in the domain space that was really important for data center to take off. And it is, to your point, very hyperscaler led. But actually, if you look at the contributions off the marketplace that people adopt, our biggest adopter, like 58% of adoptions from OCP marketplace, are telcos, are network
Yeah.
operators. So it's really, the community has changed so much over the last 10 years. And there's a lot of change that will continue to happen, I think, as, we're more heterogeneous, as data is more disaggregated, everything that we're dealing with just as a community.
Mm.
There's changes afoot. I'll put it that way.
I've noticed that over the time span that OCP has existed, I guess the biggest thing on that's currently in the market right now is AI and the sort of move to make solutions that are more AI focused for everybody to use. And to your point, 5G and telcos, that seems to be a
Yeah.
really big focus right now. So
Yeah. And in that sense, I mean, I think there's some interesting things happening with like network anomaly detection and sort of more of a software perspective for
yeah,
using AI, obviously. But in OCP, OAM is sort of where things have focused,
yeah,
otherwise known as, please don't quote me, the poor man's DGX, right? Like, what are the form factors we can help create
yeah,
so that people can choose to, take a Cerberus chip, take a different AI accelerator, whatever,
yeah.
the newest, latest, and greatest will be, and be able to take advantage of the systems footprint and validation footprint that's already in the ecosystem.
Yeah, there's Intel's quite a few AI companies recently, and they've all gone towards that sort of OEM interface sort of design
Mm-hmm.
as well. And so if we look at the companies listed, I've got Asus, ARM, IBM, Google, Microsoft, Dell, HPE, Nvidia, Intel, Cisco, Lenovo, Alibaba. That's a lot of the industry, and I think you said 3 out of 7 hyperscalers. Is OCP in the case of growing its membership, or is it at a healthy level, or are there people that need to be involved that currently aren't? You think that for
Oh
this
yeah, no,
for it to take the next
definitely.
step on?
Yeah, the OCP Foundation, in general, right now has 250 corporate members. Again, it started as 6, so
Yep.
definitely a huge number of growing participation. There's over 5,000 engineers, in 1,600 or 16,000, sorry, participants, 29 active projects across the world. Like um, and the domain spaces keep shifting and growing, right?
Yep.
So, um, obviously, security and operations specifically for security, advanced cooling, areas in connectivity solutions, test and validation enabling, right? There's been so many great papers actually recently written about the complexity of test and validation and consistency as we have more heterogeneity in systems. So there's a bunch of projects. And then one of the awesome and amazing ones that's happened in the last year is sustainability, right? And looking at
Yep.
sustainable practices, because there's zero consistency on reporting scope 1 or scope 2 emissions as it pertains
Yep.
to ICT equipment, right? But there's also zero standards around reporting out scope 3 emissions, any sort of best practices for operations, and how your laptop works going into suspend mode and whatever is
Yep.
really different than if you're trying to operate the public cloud, and you have to have a certain commitment from an SLA perspective for spin
Yep.
up latency, but you're actually not fully utilized most of the time. So how
Yeah.
do you make
Yeah.
that, really operate with an always on mindset, but not burn power if
Yep.
unnecessary, right? So sustainability has been, I'm a total hippie, so I get really excited at the prospect of us bringing that community together, because people are out there making all sorts of claims, but there's nothing standard to compare it against. So their claim,
Yeah.
as measured by, as evaluated against, as compared to,
This company we hired
yeah,
to give us the
this
good numbers. Yeah.
consultancy whose methodology has not been validated, is not
Yep.
necessarily, and this is true of governments haven't necessarily stepped up in this domain space either. But I think this is a domain space where open source communities really can. And at least
Yep.
they start, and then, others can take notice.
So, I mean, one of the recent groups that I think most of our audience is probably interested in is the open domain specific architecture, sort of open chiplet marketplace.
Heck yeah.
Because Intel's moving into that, Intel's competitors are moving into that. We're seeing, even when I spoke about AI chips, some of these designs are essentially chiplets in a big infrastructure. So that was announced kind of 2 years ago. Do you have any insight into what's going on with the sort of chiplet standards now with
So
OCP?
much and not nearly enough. But I think that you made an excellent point, which is everybody is getting into this domain space, right? Whether it's 2D or 3D, I'm sure you covered hot chips and sort of what was latest and greatest in that domain space. There's a lot of interesting things happening with 3D technologies and 2D technologies. Chiplets, it's interesting. There's three I think it's fair to say three, definitely two main things that are occurring. So ODSA itself as a working group has been working to create sort of a test chip mentality where we can actually give effectively a reference implementation of two different 2D stacking technologies, two different fabs on either side of the wire. And so that's sort of the OCP project. It's really about trying to create, and whether a bunch of wires is used or AIB is used, there's lots of things in this domain space, and we're all, evaluating based on, throughput, based on really simple things like the right to license and utilize and who so things that just require communities to come together, have the debate, have the discussion. So that's really where that team is focused, that project group is focused. In terms of when I look at what's happening in the ecosystem, there were some really interesting conversations that happened November of last year at the summit, the virtual summit, because of the pandemic. Where they started talking about this concept of an open chiplet marketplace. And this is really, kind of a brainchild out of Google, kind of coming together, bringing people together to talk not about the thermal or the electrical, what we all always think about when we actually produce these things, but the software layer and consistency. How do we create a security model when chiplets are made anywhere? How do we have, some aspects of composability and manageability and visibility, right? Try and think about, I mean, you probably remember when like NVIDIA cards started coming to the public cloud, it was like a nightmare. You couldn't, chop them up for virtual machines. And if something went wrong in the device, all the visibility went to the virtual machine. So the vendor who's providing it, as hardware vendors, we had never really thought about the world where, wait, I don't manage my hardware? What? It still happens, by the way. We're still, I think I've been obviously in this, area for 6 years, but we're coming on the 15-year anniversary of AWS. And we're still, I think, really understanding fundamentally what it takes to operate a public cloud set of hardware. It's very different. So chiplets, so much. So in the domain space of the actual interconnect, in the domain space of a marketplace and sort of how that could function to have consistent software and composability. And then I think there's a ton to figure out in terms of validation, ensuring it works, and creating it at scale. And I don't know where it goes, Ian. I mean, I'm so excited to see where it goes. This is like my typical, there's some part of my world where I'm like, oh, what if we got to a place where, you just have the robots and they're like composing the CPU or, XPU of whatever variety with all these pre-validated chiplets, and boom, you run a couple of, burn-in tests on it and you have a whole new XPU at scale, exactly what an end user needed. Will we get there? It's decades. It's decades away. But I think that's what those kinds of technologies start getting us towards.
I mean, I think it's really important that when we start moving into that sort of chiplet tile architecture, if you're buying a third-party chiplet, you want to verify that it's actually doing what it says and having a defined secure chain. Because at some point, there's going to be, as you say, robots designing these chips. You've got to make sure the robot's making it in a very secure way so that you can validate start to finish and the results you get out are right. No, that sounds like the right path to do. And
and we're going to crawl first, which is just getting these things to do 2D stacking together from two different foundries on two different sides of the wire to do a different and unique use case. But we'll get there. And I think that's getting there is, it never happens if people don't come together, right? It just can't.
So OCP, the O stands for open, right?
Yes.
But to become part of the OCP, you have to pay to be a member. But all the meetings for everything seem to be online, so anybody can watch them. They're all, if you're interested in watching the OCP meetings, they're all online, unlisted videos. But if you go to the OCP website, they're all listed there. So what exactly does O in open mean if it's, a sort of a pay to get involved sort of group, collaboration, industry, what have you?
It's a good question. It's actually not. So to me, open, it's about open hardware, right? It's about
Right.
creating specifications that anybody can pick up, whether it's Quanta, Foxconn, WeWin, anybody can pick up and produce, and helping ensure that therefore there's more consistency from, again, the modularity of the compute itself, but even at scale operations. So management, security, solutions in that domain space. So to me, open is about the specifications that are contributed versus, necessarily the participation. The
Right.
foundation has to pay for its
Survive, yeah.
people and administering them and ensuring that, those happen. I would say it's a fairly, wearing my OCP hat, I would say it's a pretty nominal fee for what it
Yeah.
does in the community. Um, and I think it's, and then there's the summits and all the different events that it does, that again, that monetary part isn't about the community it serves. That's really driving open technology and solutions is what it serves, versus, again, anybody can get involved, anybody can learn from it. I think the opportunity to be a voting member of the community and elected, part of the various working groups or incubation committee, those things require membership. And that membership really is about, you contribute financially, you contribute with your time, you actually have to make contributions in order to ensure that you are in fact listened to, right? Committed to driving these contributions.
Yeah, it sounds like you can't really be a passive member in that sense. You definitely have to be
No,
involved.
somewhere, right?
Yeah.
There are definitely, particular working groups that may not be interesting to you, but the expectation is it's a very active community. When I joined
Yeah.
the board, I still remember Mark telling me, Mark Ronick, who was the previous chairperson, he was like, "We are a working board, Rebecca. The expectation is you're going to get things done. And here's how I have set up my support network
Yeah.
to be able to do this for this long." And I took notes.
Yeah.
I don't do it on my own. There's no way.
So with respect to what I think most of our readers might interact with OCP is the standard sort of OCP server rack design. I think you mentioned Olympus earlier. This sort of drive to having more efficient servers, helping with cooling and density. The specifications of, say, an OCP server right now, I think it's version 3, are like wider than a standard server, and the racks are slightly taller, which is completely different to how most of the time we look at enterprise systems, right? So why hasn't the industry moved to what OCP suggests and kind of stayed in its lane? As I say this as you're somebody who works for Intel, and Intel's partners sell a lot of those regular systems, right?
Yeah. So OpenRack started, that design form factor as the 21 inch instead of the 19 and all these
Yeah.
others, really, started for a very specific kind of single socket, but super dense single socket design.
Yep.
And it's a phenomenal design. OpenRack continues, in the ecosystem. But it's not the only OCP certified. So if you actually look, like Mount Olympus is 19 inch and a standard server configuration. So you'll see both, and Google has made contributions that are 19 inch as well. So, you see like the form factor is absolutely compliant for OpenRack, but it's not necessarily true that every contribution in the marketplace adheres to that
Right.
original OCP form factor, which was really about, Facebook creating a very unique, very low PUE, dense compute design. So
Facebook
everybody,
being one of
and I
the
love
founders.
founding members,
Yeah.
exactly.
Yeah.
And I love what they did there. There's a lot of different people, and if you know the kind of Open 19 started because people were like, why did they do this weird thing? And then, there's
Yeah.
been all sorts of and then OCP was like, well, we embrace all. And so we'll have
Yep.
19 too. So, it's, I think it's been an interesting journey where, because so much of the original designs were contributions from hyperscalers in partnership for their specific
Yep.
environments, but then, as the community has grown into, telcos, into more enterprises, as the board
Yep.
membership has changed, right? Rack space, etc.,
Hmm.
people are thinking about it differently. And so there's
Yep.
more of a expansion, I guess, in the form factors that are available.
Do you think or rather does OCP actively search out technologies it feels that it should incorporate into some of its open standard designs, or do you rely on the companies with those technologies to become part of OCP? Is it sort of like a pull or a wait and see or sort of approach?
It's a great question. When I came into the board, I had a very similar question. Like, so how does this work? I know what
Yeah.
we do, I know what we think about, and it's a pretty proactive process
Mm.
from our lens. But how does new membership work? How do new initiatives work? So, as a board, actually, we sat down and spent days and days together virtually, because it was during the pandemic, to come up with, where is the puck going? What do
Yep.
we see as the future initiatives of the world? Computation is increasingly heterogeneous. Data is increasingly disaggregated.
Hmm.
Sustainability is incredibly underserved, right? And we kind of tried to create both the pain points of our various lenses on the industry, as well as the changes in opportunity space, and report it out to each other. And out of that process, we came up with the OCP 2.0 framework
Yep.
that we're in the process of rolling out, which is, two fundamental goals, right? Meet the market of today. And that's traditional OCP, what we've always done,
Hmm.
modularity, at scale operations, increasingly sustainability. And it's a top pillar of meeting the market today, because I think we're already late, frankly. And then the integrated solution space, right? So if you think about how much money and time various vendors spend just to
Yep.
certify different solutions, SAP certifications, ensuring that vSphere runs correctly in
Yep.
all these different configurations, it's a huge amount of time for the industry. So
Yep.
how can we do that better, faster, stronger? That's meeting the market today. And then the other aspect of it is, again, understanding the future is more heterogeneous, more disaggregated, and different technologies need to be in place.
Yep.
Optics needs to be developed, not just, from a network switch perspective, well covered. I don't need
Yep.
to
Yep.
work on
Yep.
any standards for network switches, for silicon photonics or otherwise. People are there. But for node level
Yep.
integration at the optics point of view, when does copper lose? I mean, copper's
Yep.
amazing, has continued to go, but like there's a point at which we're going to have to make those changes. It's going to be a chiplet integration. How are we going to make sure the modules for optics can go into advanced cooling systems?
Yep.
Light has different behavior when
And
you're
it's all
when
packaged
you're
incorrectly, and
liquid.
yeah.
Yeah. So how do we make sure that we're building something that actually will work, in all those different environments? So optics was a big area of focus for us, for kind of seeding future innovation, open silicon initiatives, right?
Hmm.
Understanding all the different dynamics that are happening in the industry, whether it's our IDM 2.0, whether it's key acquisitions that have happened in the ecosystem, general consolidation, fewer foundries available across the world, all the different AI chiplets that you mentioned earlier.
Yep.
These domains are requiring more and more partnership at different layers than we produce a product, they produce a product, we all use PCIe
Yeah.
to work together. Woohoo! Very different. I mean,
Yep.
CXL itself is, starting to understand, like, now I need to have a fundamental understanding of the TLB on a device that is not my own.
Yep.
Phenomenal. It's
Yep.
going to go great the first couple of ones we do, I promise. So, and again, I mentioned optics with cooling, but cooling anywhere, like how we think about cooling at the edge in these tiny co-location facilities versus cooling, in a more hyperscale, or let's go back to the beginning, like HPC invented this stuff, right? So there's fish tank designs and cold plates and all sorts of cool things that are going to come together. How do we make sure that every single one of those things is not a new research project that takes 2.5 years, but can become a commodity way we think about it? I don't know about you, but I grew up loving Fry's Electronics, and like I still remember that old, they had the gaming system immersion cooling solution. It was really kind of a cold plate solution where it went through the front, and it was so cool and it lit up, and I just thought it was the coolest thing I'd ever seen. We need like the server equivalent, maybe without the lights, but like, it needs to be easy for us to take advantage of those technologies, because fundamentally that will make our overall power footprint in this industry more efficient and effective for serving the incredible demand that exists. So that's OCP 2.0. That's feeding future innovation. That's what we want to do. We have a lot of aspirations, we had to get it done.
I was going to talk about the Future Technologies Initiative, but I think you've basically covered it there as well. It's fantastic.
Well, what's interesting about that one, Ian, is that was a community-led initiative, right? The Future Technology Symposium started with the community, and the board was kind of like, okay, well, we'll let that happen, as opposed to kind of saying, hey, wait a second, where do we really think the future technology is going? And so now we've done, I think, a good mapping between what was already in the Future Technologies Initiative work streams, because that started in like 2019, and what we kind of decided as the board level. But yeah, future technologies, it's interesting because they're more about service models, like the cloud service model one, or AI hardware and software co-design, like recognizing this domain space of heterogeneous compute exists because you will no longer be able to run sort of general purpose computational solutions that are not deeply aware of the software running on top. And meet the needs of AI. Right? It's just not possible. And then software defined memory, I already hinted at CXL and the insanity of what's going to happen there in terms of device models, just completely different device models than anything that we sort of grew up with on assumptions for IO. So the industry is just so, it's amazing. I mean, that's why I'm in it. So
your enthusiasm is infectious, I have to say.
Yay!
It's crazy. So I know we're coming to time, but thank you so much for spending your time to speak with me and speaking to our audience about OCP. Good luck.
Thank you. I need it.
It's great to hear as and when more things come out of OCP. Thank you.
Thank you.